The last section of Chapter 4, Section 4.5, is titled Matrix Inverse and Solving Systems. We're going to go over how to find the inverse of a matrix, and then we're going to use the inverse of a matrix to solve systems of equations. It'll actually be a technique for solving systems that's a little faster than Cramer's rule, and one that you might like even better than substitution and elimination methods from back in Chapter 3. Okay, inverse matrices. Let's see. Only square matrices can have an inverse, but not all square matrices do. Okay. And the product of a matrix and its inverse is the identity matrix. Okay, so what's the identity matrix? Well, that's the next one to define. The identity matrix is a square matrix having ones on its main diagonal and zeros everywhere else. Okay, so for a 2 by 2, looks like that. For a 3 by 3, looks like that. You can see just the ones start in the top left, go to the bottom right. That's the main diagonal. For a 4 by 4, the identity matrix would look like this one, etc. And just continue to grow from there. First example, are the following matrices inverses? Well, we said when we defined inverses that the product of a matrix and its inverse is the identity matrix. So what we want to do is multiply these together. 4, 3, 2, 1 times negative half, 3 halves, 1, negative 2. And remember, when we multiply matrices together, I have to go back a couple of lessons to review if you need. We take rows on the left and columns on the right. Okay. So let's check and see. First row times first column, I'll do the work down here. 4 times negative half is negative 2, plus 3 times 1 is 3, that's 1. So we're good so far. First row times second column, 4 times 3 halves is 6. Plus 3 times negative 2 is negative 6. That's 0, so we're still good so far. Second row, first column. 2 times negative half is negative 1. 1 times 1 is 1. What's 0? We're still good. The last spot, second row, second column. 2 times 3 halves is 3. Plus 1 times negative 2 is negative 2. That's 1. It's 1. This is the identity matrix, so yes. Yes, these are inverses. Well, I think the next logical question that follows from that example is, if we have an inverse, or if we have a matrix, can we find that matrice's inverse? Instead of just verifying if two matrices are inverses, can we actually find the inverse of a matrix? And we can. We can do it for any size, really. I'm going to give you a shortcut formula for a 2 by 2, and then anything bigger than this we're just going to use our calculator to do, and I'll show you that also. So here's how we do the inverse of a 2 by 2 matrix. The a to the -1, that -1 power indicates inverse. We do 1 over the determinant of matrix A times D -B -C A. Okay. So we need to be able to find the determinant, which we can do. We take the numbers that are on the main diagonal here, the A and the D, just switch places. The numbers on the secondary diagonal, they don't switch places, but they switch signs. Okay, so positives become negatives and negatives become positives. Okay. This fraction would then just distribute to all the numbers inside the matrix. So let's show a couple of problems of that. Alright, when I find an inverse, the first thing I do is I go ahead and just find the determinant. The determinant of this matrix, I would multiply, that's 8, minus, multiply, that's 6. The determinant is 2, so the inverse of this is going to be 1/2 times, these numbers I switch places, these numbers I switch signs. And now I just distribute that half. So I get -2, -1, -3/2, -1. There's my inverse. Okay, next example. I again begin with the determinant. So 8 times 1 is 8, minus 4 times 5 is 20. So the determinant is -12. Okay, so the inverse is -1/12 times 8 and the 1 switch. The 5 and the 4 become negatives. And now I just distribute that fraction in. If I can reduce any fractions, I go ahead and do that too. So -8/12 would be -2/3. And then I'm going to have +5/12. I'm going to have +1/3. I'm going to have -1/12. There's my inverse. Now let me show you how to find the inverse on a calculator. Let's use this one right here. Okay, I'm going to go into matrix, I'm going to edit. The size is 2 by 2, 1, 5, 4, 8. So typed in, I'm going to quit and get out of that screen. I'm going to go back into matrix. I'm going to pull out that matrix where I just typed it. And the button that we've been going to get into matrix that's got a -1 exponent on it right there, just hit that button without hitting the second first. That's your inverse button. Now it's going to find the inverse of matrix A. Now it's got all these weird decimals that come from fractions. Let's convert those those decimals into fractions. I'm going to hit math, enter, enter. There's my answer in fraction form, and then you can compare it to what we have, and it's perfect. So that would be how you would want to find the matrix or the inverse matrix for 3 by 3, 4 by 4, anything bigger. You can even do it with the 2 by 2, of course, as we just showed.